whenever I talk about factoring, I always talk about how we get there in the first place. You'll see what I mean by that in a second. Because I think it's a really good way to always, like when you're factoring, don't get caught up in just doing the steps, but think about why it works. I think can always be really helpful. So if I were to scratch this out, and if I started with this expression, and I was going to expand it, how would I do that? I'd multiply these two things here, and then I would multiply these two things like this, right? So you'd end up with 4 terms, and we recognize this pattern, hopefully. 2 of them always add together, and I'm left with a trinomial. So let's do it. 3x times 2x is 6x squared. 3x times 3 is 9x. 1 times 2x is 2x. And 1 times 3 is 3. And then these two middle terms, they're not always in the middle, but usually our brackets are set up in such a way that it's the two middle terms. But it's because they're like terms, they're both x, so 9x and 2x is 11x, and we would still have the other terms. And that's the thing that we hid before. So, yep, looks like everything's right. 6x squared plus 11x plus 3. That's expanding. That's the easy part maybe because you just do it and the answer works itself out. Okay? So that's expanding when you go this direction. When you go the other direction, if I were to give you this and tell you to factor it, that's going the other way. If you want to write down those steps, you can. They'll be online if you want to look at them after. I'll give you a minute to do that. For this process, it might be useful. It's only 3 things, right? And all 3 of them, I think you can kind of understand what they're saying. Or maybe 2 might be a little bit hard, but step 1 and step 3 are very useful to write down because sometimes people forget them. That's maybe the part that people forget, especially when you're first seeing it. Now, you guys have seen it before, but first time seeing it this year, it's a little bit strange. Factoring simple trinomials is usually really easy. You just are looking for 2 numbers that add to something and multiply to something, right? Everybody remembers that? Complex trinomial factoring is quite a bit harder, I would say. So, you know, it's something that some people consistently struggle with. In grade 10, it's something some people never quite get. It is a bit of a more challenging algorithm. And it's a strange one where it's almost like magic. You don't really understand necessarily why it works. I mean, you can obviously look at why it works, but a lot of people don't necessarily understand why it works, but it works every time. It does just work. And so it's kind of this, it seems almost magic, but it's not. It's math. There's a reason why it works, but it kind of seems magic. I don't know about you, but I think some people feel that way. Okay, so if you want to write those down, you can. And the trick is, just watch for a minute, that these 2 numbers multiply to this, and these 2 numbers multiply to this, right? Actually, let me do that. These 2 multiply to this, and these 2 multiply to this. But then where do the middle numbers come from? That's what we're trying to figure out. You guys okay? Yeah? Okay, so let's see how this plays out. We're going to just do a whole bunch of examples here. What makes it a complex trinomial, first of all? We should probably point that out. Does anybody know? What makes this different from a simple trinomial? Very good. This has a coefficient that's not 1. If it was a 1, it would look something like this. X squared plus 7x plus 12. And I would be looking for 2 numbers that multiply to 12 and add to 7. Does anybody know what they are? 3 and 4. And the trick to factoring, and this is still true for complex trinomial factoring, is you have to know, this is why it's a little bit trickier, a little bit different of a process from expanding. You have to know what the answer is going to look like. I know that the answer is going to have 2 brackets. It's going to be x plus 3 and x plus 4, because this is an easy one, right? And I know that's what the answer is going to look like. So part of factoring is you have to know that's what the answer is going to look like. And we know that for complex trinomial factoring as well. It's going to look like this and like this. But we're not just looking for 2 numbers that add to this and multiply to this. We kind of do that eventually. We look for 2 numbers, or we look for them adding to something, but it's trickier because of the complex trinomial of the 3 out front. Okay? So here's how the process works. Here's how this algorithm works. If I go back up, step 1 says list the factors of the coefficients of the first and last term. So that first term, if it's written in proper order, right? So the coefficient of the x squared term, I write those, I write out all the factors. So what are the factors of 3, 1, and 3? That's it. 1 times 3 is 3. There's only that one option. Okay? If I had like a 6, I'd have to write out all of them, right? But for 3, it's an easy one. Then we draw a line. Then we write out all the factors of the constant. So in this case, the 2. So 1 and 2. It's a good idea to do it in order to make sure you get all of them. We don't usually have a lot. There's a couple of examples in this lesson that we're doing that have a lot, but usually you don't have that many. Does anybody remember the other thing that we have to remember when we're writing out the, like, how familiar is this from last year? Does anybody remember what we have to do next? Sir? We got one thing before we do that. But you're right. What do you think? We have to take either the left side of the line or the right side of the line and flip them and write them all down again. Now, in this case, I only have one of each, so it doesn't matter. I would always pick the side that has fewer pairs of factors. So in this case, I'll do this side. So you have to flip one side and rewrite them all again. So you have all of them one way and then all of them flipped. And once you do that, as long as you've got all the factors on both sides and you flipped one side, you've got all the combinations in front of you, and now we just have to figure out which one's the right combination. And Sarah was describing it properly of what we do next. Do you have a question?
Yeah, if we have multiple, like if it's like
yeah, you got to flip them all. That's right.
So will there be multiple different, like
yeah,
in the combinations, if there's like 3 different numbers, how do we know where to put the 3 that are flipped?
Well, you'll see when it's huh?
Do we have to do 2 lines?
No, you'll see. Well, how about you wait till we get to that example? You literally just think of which, it doesn't matter. You can flip whatever side you want, and you can flip them both, but then you would have a lot of extra work to do. But I would pick the side that has the fewest pairs, and you just flip them and rewrite them just like we did. But we'll see it when the next example probably will have, or maybe example C we'll have to wait for. Now, are you ready for this? This is where the magic happens. So we are cross-multiplying. We're multiplying across the line, one from the left of the line and one from the right of the line. And we multiply across. So what that means, watch me do this. I'm going to do it up on the board so you can see what I'm doing with my hands. I'm going to multiply the top on this side with the bottom on this side. Actually, I'm going to start with this one. So 1 times 1 and 3 times 2. So I multiply, and then I switch and multiply again. Does that make sense? You remember this now? Coming back to people? No, I'm getting no feedback from you. What's going on here? Okay, and so in this case, don't write this down. 1 times 1 is 1. 3 times 2 is 6. 6 plus 1 is not 5. I'm looking for them to add up to that middle term. Sometimes they subtract to the middle term, but sometimes they add up to middle term. In this case, they're going to add up to the middle term. And they do not, because it was 1 times 1 is 1, 2 times 3 is 6, 1 and 6 is not 5. So those are not my numbers. So now I'll do the other ones, and it's going to be these two. 1 times 2 is 2. 3 times 1 is 3. I like to circle them like this when I find them. I would use a pencil in case you change your mind afterwards. You can erase it and fix it. And 2 plus 3 is 5. So we are still adding them, but you got to multiply first. And it's like you're doing this little dance, because you go like this and then like this. And you got to keep trying all the different combinations. And I would do them in order systematically until you find the ones that add to, in this case, the 5x. Yes? No, because we're not subtracting in this case. We have to be adding, and I'll talk about why at a different example. Just go with it well, we'll talk about it briefly in this one, but it's more interesting when we're not adding, when we're subtracting, and we'll talk about that then.
When you circle it, I thought we don't have to circle it diagonally.
You could circle diagonally. I do it like this. If you had a long list, your diagonal circle would kind of go through everything, which might be fine, but this is how I circle it. I circle the pairs like that.
So you're multiplying the pairs?
You're multiplying across.
Oh, okay.
And you're multiplying the top with the bottom and the bottom with the top, like that. Yeah. And then the step 3, this is the one that some people get confused with or get wrong. You read your answer across the page. So my answer actually looks like this. Those ones go together and those ones go together. But again, I don't circle across, because you'd circle a whole bunch of other ones as well. So there's the numbers that go together. Like the top one will be my first bracket. The bottom one will be my second bracket. So now I'm going back over here. And this is 1x and 1 and 3x and 2. And then you figure out your signs, but in this case, it's a simple one. Everything is positive. So I would actually write this as x plus 1, not 1x plus 1, but and 3x plus 2. It's like magic. The answer just kind of pops out of nowhere. It seems strange at first, maybe, but it's doable. It's one of these things, and you guys have seen it before, so maybe you're not as intimidated. But in grade 10, when you first show this to somebody, they're like, what in the world? I don't even know what you did. You're doing this with your fingers, and you're writing down numbers out of nowhere, and then all of a sudden you're writing down the answer. I don't even know what's going on here. Do you remember that from grade 10? It's very strange. But if you practice and you keep at it, and you follow those sort of 3 steps, all of a sudden you get really good at it. You can get really fast at it. And it's this strange thing, but it's a neat little algorithm, I think. Everybody good? Try another one. You're only going to get good at it by trying it. So make sure that you practice, practice, practice. We've got like a whole bunch to do together here, but then there will be time in class for sure for you to get some practice done on your own, and I'm going to let you do some of these on your own. But the first few we'll kind of do together. Write it down, and then watch what I do again. I'm going to write equals, and I'm going to write in the brackets. I recognize this is a trinomial. I'm factoring it. I recognize it's a complex trinomial. So I'm writing out the brackets. This actually will help you like put your brain in the right mode for factoring. Like just writing that out will help you probably get into the right factoring mode. So I'm going to write down all the factors of 2, and it's important that you do we are using y this time, but the y squared, it's important that you do that first. That has to be on the left. So 1 and 2. And then I'm leaving a little space because I know what's happening, and then a line. And then on the right side, again, it has to be the y squared's on the left and the constant on the right. 1 and 10 and 2 and 5. Right? Because 10 has 2 pairs of numbers that multiply to get 10. But that's it. I think that's all of them. There's no more. And now I have to pick either the left or the right to flip all the factors. And this is where, like, I'm going to pick the left this time, because then I only have to flip one thing. If you pick the right, you'd have to flip them both. So you'd have 4 written out on the right. It's easier to do the left. Ben, you have a question?
Why are we using 2y?
Because that's how it works. You always use the coefficient of the squared term and the constant. Those are the ones you always use.
Last time did we use 5x?
No, we used 3,
Oh, we had to, okay.
but they add up to the middle term. So that's the next part. So in this case, you're exactly right. They're going to add up to 9. And everything's positive. I actually skipped over that last time, but why is everything positive? If we go back to the last example, you can see that 1 times 2, they'll be the same sign because it gives me positive 2, right? So when I look at this number, it's positive, so I know they both have to be the same, but in this case, positive. Okay, and it's the same thing here. The 10 is positive, so everything in this case is just going to be positive. Did you have a question?
Yeah. Can we just put it as like 2 and 10, and then underneath the 10 write all the factors in a line, and it can be messy? Like, can we?
It can be as messy as you want it to be. I wouldn't write it a different way. I'll look at what you're doing after. I would be careful. This is the best way I've ever seen it to be done. So writing it vertically or something, I'm worried that that might not be as easy. It can be messy. In fact, you don't even have to do it. If you get really good at this and the numbers are small, you might be able to just do it in your head. Okay?
Do you have to show that work?
You don't know. This is what I'm saying. You don't have to write any of this. There's no work to show. You just write the answer to these. So it can be as messy as you want, that's for sure. Or some people do it on a separate sheet of paper, like scrap paper or something like that, for like a quiz or whatever. Okay, so here we go. I'm going to bring this down and I'm going to do it up on the board in front of you. So I'm going to start with, I'm looking for a sum of 9, numbers that add to 9. So watch how this works. 1 and 10 and 2 and 1. So 1 times 10 is 10, 2 times 1 is 2, 10 plus 2 is 12, not 9. 1 times, and I can try the other ones. I would start with this one and try both. And if I don't find it, move to this one and then try both. And if I don't find it, something's wrong, because every time the answer will be there. Okay? But I'm going to skip over the right one to just show you what it looks like to do more of them. 2 times 5 is 10. 1 times 2 is 2. 10 and 2 is 12. 2 times 10 is 20. That's not even close, right? So I know that's going to be wrong. I can just kind of stop. But 2 times 10 is 20. 1 times 1 is 1. So 21, not right. Where's the right one? 1 and 5. And 2 and 2 is 4. 5 and 4 is 9. So again, I'm going to circle them like this. And I go 1 times 5 is 5. 2 times 2 is 4. 5 plus 4 is 9. Oops. Oh dear. Is 9. What do you think? So then we read our answer across the page. So that's 1x, or x and 2, and 2x and 5. And notice how I always write them in like that first and then do the signs after. But in this case, it's all positive, so there's not too much to worry about with the signs. Oh yeah, it's not x, it's y. Is that what you were going to tell me? Yes, thank you. I always do that. 2y. I always forget that the letters, I just use x. Any questions about that? Is anybody nervous about this because they hated it the first time around? They don't want to have to do it again? Or is anybody like starting to remember this, or it's easy, or you're good at it? How's everybody feeling? All right. Let's try another one. What's different about this one? That's right. So what does that mean the number is? It does have a number, you just can't see it. Huh? It's a 1. That's right. It's a -1. Good. What else is different about this one from the other two? It's got negatives in it. Exactly. So put your pencil down and watch carefully. Remember when I said it's important to think about where it comes from, and how these two numbers that I've got highlighted in blue multiply to that third number, that constant. So if my constant is positive, I know the numbers have to have the same sign. Because a positive times a positive is positive, or a negative times a negative is also positive. And because this number is positive, they're both positive. Does that make sense? But this one is negative. So one of them is positive and one of them is negative. And we don't know which yet. So I'm going to leave that to the very end. But I know that they're going to be negative, which means after we write out our factors and we do the little dancy cross multiply thing, we're going to find the difference between the numbers. We're looking for a difference of -1 or of 1 is what we're going to be worried about. Okay, so let's see what this one looks like. I'm going to start writing out the factors. 1 and 6 and 2 and 3. Is that all of them for 6? 12 has more factors, so I'm going to flip these ones. So this is what it's going to look like. I'm going to flip this one, 3 and 2, and then 6 and 1. And then draw a line. 1 and 12, 2 and 6, 3 and 4. And that's all of them for 12. So I would have had to flip all 3. Any questions so far? Is everybody okay about how we got those factors? We're looking for a difference of 1. Again, if you want to watch, I go like this. 1 times 12. So 12, 6 times 1, 6. 12 minus 6, not right. 1 and 6, 6 and 2, that's 12 and 6 again. 12 minus 6 is not 1. 1 and 4, 6 and 3, 18 minus 4 is not 1. So I just checked that pair of factors with all 3. None of them worked. So now I'm moving on. What's 2 times 4? 8. 3 times 3 is 9. 8 minus 9, or 9 minus 8 is 1. So there's the one that we're looking for. So it was this one and this one. I kind of skipped to that last one, I guess, because I knew that's the one that was going to work. This one's not 2 and 12, 24 and 3. No, not going to work. 12 and 6, again, not going to work, right? So I found it when I did 2 times 4 is 8. 3 times 3 is 9. 8 minus 9, or 9 minus 8 is 1. So now, watch how I'm going to write this. I read my answer across the page. So I do 2x and 3. No signs yet. And 3x and 4. Oh, it's b. See, I did it again. 3b and 4. And now I'm going to figure out where I get my signs. And it's going to be 2b times 4 and 3 times 3b. So 3 times 3b is 9b. And then 8b. And I need the 9 to be negative. So that it's -9 plus 8 gives me -1. So this is where I got 9 from. So I put it on that one. And this one's going to be positive. Some people call this the smile twice method to check. Always, always, always check. Smile twice to check. You got a small smile and a big smile. That's how you check your sign, but it's also how you check that you got the right numbers. And again, I can do this. I can go like 2b times 3b is 6b squared. -3 times +4 is -12. And then again, smile twice. 8b minus 9b is -1b. All right, we're going to do one together, and then I'm going to let you try one more together, and I'll let you try one on your own. Well, you can try to do this one on your own if you want to race me, but I'll kind of do it along with you. Almost everything we do in this unit is going to involve factoring. So unfortunately, if you don't learn how to if you don't get good at factoring, now some of them are going to be simple for sure, but some of them will be complex or tricky trinomials. And if you don't get good at doing that, it's going to make everything else we do harder. So like today and tomorrow are going to be two of the most important days of practice, 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 ask questions, make sure you're good at it, make sure you understand, and even make sure you're fast at it. Like you don't want this to take you all day to factor a few of these. First step, write down all the factors. So 1 and 12, 2 and 6, 3 and 4. Draw a line. 1 and 5, flip it, 5 and 1. Everybody get that? Take a look at this one. It's a little bit different. The 5 is positive, so the numbers will have the same sign. Remember, these two numbers, the constants at the end, are what will multiply to give me 5. They have to have the same sign. But the middle term is negative, so both will be negative. Does that make sense? See how there's the different combinations? Both are positive, or both are negative, or they're different signs. All right, how do we get 32? Some people get in a habit of just kind of staring at the numbers. That's fine, especially if you get good at this. Sometimes it's like amazing what happens, but you get good enough that you just kind of figure it out. Like you kind of look at all the numbers, you're like, I think it's these ones. And you're right. And you're almost always right. Like people get very good at this. But I wouldn't stare for more than a few seconds, and then I would start trying things, literally with my fingers, and crossing possibilities out. 1 and 5 and 12 and 1 does not add to 32. 1 and 1 and 12 and 5 does not add to 32. 12 times 5 is 60. Not even close. So that one is gone. 2 times 5 is 10. 6 and 1 is 16, not right. 2 and 1 is 2. 6 and 5 is 30. 30 and 2. So there they are. So this one with this one. 6 times 5 is 30. 2 times 1 is 2. 30 plus 2 is 32. So I got 2a and 5, 6a and 1, and both are negative. So again, go back, do your check. Negative 5 times negative 1 is positive 5. 2a times 6a is 12a squared. And then smile twice, and I go negative 2a and negative 30a is negative 32a. Could you check? Yeah. What do you mean?
Like when you put the negative 30
Those are just lines.
I do it differently. I put the negative on the right side of the thing before the number, and I do like,
In here?
yeah,
I wouldn't do that. There?
yeah. That's how Mr. New said it.
As long as you're getting the right answer, it's fine. I wouldn't put the negatives in here because you don't know which one's going to be negative. We don't know until the end which one's going to be negative. Huh? Well, I don't know. I'll come and see I'll come around right now and see what you're doing. I'm going to let everybody try another one. But what you want is, we know that we're, like, I don't care what's positive or what's negative. All I care is that I need to add to 32. Not negative 32, not positive, just 32. That's all I'm worried about. And then I find my numbers. They're 30 and they're 2. 30 plus 2 is 32. And then I write it in, and then at the very end is when I think about the signs. That's how I do it. There are different ways of doing it. In fact, there are at least 2 other totally different algorithms for doing this process. So if anybody really can't do this, it seems strange at first, but this is the fastest and easiest, trust me. So try. But if you really can't do it, I can show you other methods of doing it.
I think what you're saying is, like, can you make, instead of the negative, like
2 and 6 negative?
Can you make the 2 and the 6 negative?
Like, instead of making, like, it's 2a minus 5 and 6a minus
So you're saying could it be 5 minus 2a?
No. I'm saying negative 2 plus 5. Yeah.
Say that again, negative 2.
And negative 6a plus 1. Yeah.
Yeah. You could do that. Why in the world would you? How is that easier?
Because then you do like, I do it like, I don't know how, like when I put the numbers there, you do the ones that add together, so like it'd be 2 and 30, and
Yeah.
then u equals negative 32, and then you just figure out which one is negative, which one's positive to make it equal negative 32.
It is very unconventional to write it this way compared to this way. They're both correct. We never write it like that. I think you can. I think you should try to avoid it. Because it's gonna make a lot of the stuff that we do with this process harder. This is the way we always write it. And when we're gonna start solving equations, it doesn't really matter. So you can, but I would try to write it like this first. And if for some reason, like I'm surprised that you think this is easier. To me, it looks they're identical. Like it doesn't make it like it's the same. But I'm going to come over and chat with you and see what it is because it's correct. So you could write it that way, but trust me, I think you want to try to write it the more conventional way. Any other questions? Okay, I want you to try one on your own. Try this one. How do you know which numbers go with which?
Just because
You're just doing that part in your head?
yeah.
Like making sure. See, that's why this one isn't the same as what I'm doing. It's because when I do it, mine are lined up with each other. So, like, 2 and 6 go together because they're together. So that's not the way you've drawn, the way you've done it. That's not the case. But if you're just doing that in your head and you know that one of them, if you're using 2, then the other one has to be 6, then you can do it that way.
Okay. So
Like,
these two.
or you can't use 2 and 12, is what I'm saying. You
Yeah.
can't use 2 with 12. Or you can't use 2 with 3.
I know these.
So as long
these
as
two
you never
numbers
make
have
that
to add
mistake,
12,
then it's
these two
fine.
numbers have to add 5. If I do that.
Multiply 2, yes.
Yeah, that's fine.
Yeah, if you're doing that part in your head, then it'll work. All right, so we're going to do 1 and 3, and I'm going to flip this one because there's only one of them. 3 and 1, 1 and 10, and 2 and 5. And it looks to me like 3 times 2 is 6, and 1 times 5 is 5, and 6 minus 5 is 1. Did everybody get that? Okay, so I've got x and 2 and 3x and 5. And I want, so this is giving me 6x, and this is giving me 5x. So I want it to be 6x minus 5x. So my negative sign should go there. Any questions? Okay, keep going. I'm going to leave those last 4 up there. F is a really hard one, so give it a try. It's got a lot of factors. It's kind of a pain. Very rarely would we have one with this many. But we're going to try it kind of once. It matters. Yeah, totally matters, because this is going to be 3x and 2 and x and 5, which is wrong. Because this is 3 times 5, which is 15, and 1 times 2. 15 minus 2 doesn't give me.
So what's the difference between
That's why we flip it. What do you mean, what's the difference? They're totally different factors. 1 times 5 is 5. 3 times 2 is 6. Right? Yeah. Some people start getting good at doing it without writing out all the factors, like I said, and that's fine. If you can get the right answer, you get the right answer, that's fine. But again, especially one with like big numbers like this, I wouldn't just stare at it for too long before I started writing something. You know what I mean? So, and I don't just mean the brackets like this, but I'd be like, oh man, 53, that's a big one in the middle. Like, oh, this is tough. And you're like, yeah, I'm not sure what it is. I'm going to write out the factors. Even if you don't do it every single time, write out all the factors. You should know how to do it in case you're stuck. And then on a test, sometimes we get nervous and our brain doesn't work quite as well. So then just start writing them out, okay? And just start trying them. Start eliminating possibilities. The other thing that I was going to say was, if you get halfway through and you see what the answer is, you could stop. Like, you don't have to write out all the factors. I've seen teachers do it where they just pick like 1 and 18 and 4 and 5. Like they pick 1 for 18 and 1 for 20 and try it, and it doesn't work, and scratch it out. And then like 2 and 9 and 5 and 4 or something like that. And then if it doesn't work, scratch it out. Like I've seen lots of people do it lots of different ways. It's just my preference. I like to write them all out, because then you know your answer is there somewhere. And both 18 and 20 have 3 pairs of factors, so I'm going to flip these ones. So 6 and 3 and 9 and 2 and 18 and 1. Oh, what a pain. 1 and 20, 2 and 10, and 4 and 5. Hopefully you've got this one done already. I think this is my answer. 9 times 5 is 45. 2 times 4 is 8. 45 and 8 is 53. So 9a and 4 and 2a and 5. And they're both negative because negative 4 times negative 5 is positive 20. But then negative 45 minus 8 is negative 53. That's a hard one. You won't usually get them that big. Any questions before we continue? There's something else I was going to say. No, everybody's good? Yep.
Does it matter like order?
Good question. No, absolutely not. If it's 2a minus 5, 2a minus 5, and 9a minus 4, same thing. Yep, order doesn't matter. Okay, keep going. So I always start with 1. And I go like, okay, so what does 1 go with? Because it always goes with just a number. And then I'm like, does 2 work? Yeah, 2 does. And 2 times 9 is 18. What about 3? Yeah, 3 works. 3 times 6. What about 4? No. What about 5? No. And then 6 while I'm back here. 4 doesn't go with 18. Not even. So then, like I said, I flip. So 6 and 3, 9 and 2, 18, 1. And then I go 1 and 20. What about 2? Yeah, that works. What about 3? No. What about 4? Yeah. And then once you're like 5, it's already there, so then you know you're done. Makes sense? All right, this one looks like they're going to have different signs, so they have a difference of 1 because this number here is negative. So 2 times 2 is 4, 3 times 1 is 3, 4 minus 3 is 1. So those are my numbers. And I put them in 2m and 1 and 3m and 2. And which one's going to be negative? It's 4 and 3, right? I want the 4 to be positive. 2 times 2 is positive 4, so I get positive 4 minus 1 times 3 is 3. 4 minus 3 is positive 1. Adding up to 29. And everything's positive again here. How many people are done this one? Not everybody? Okay, I'll give you another couple minutes. You can get started on the practice. 15 minutes left of class. I start with this one and I try this. So 1 and 20 and 18 and 1 doesn't work. 1 and 10, 18 and 2 doesn't work. 1 and 5, 18 and 4 doesn't work. So cross that out. 2 and 20 and 9 and 1.
Wait,
nope.
So you did 1 and 18 with all of these?
I tried it with all of those.
Okay.
Didn't work. So I know it's not that one, and then I move on to the next one. You can see why, like, even back in elementary school, when your teachers were hopefully talking about the importance of knowing your times tables. and then there's, I don't know if you've noticed this, but there's been a lot of like controversy over whether or not we should make kids memorize times tables or whatever. But for this kind of a process, if you can multiply quickly in your head instead of having to do everything on your calculator, it's just faster. You can certainly do it, but knowing the factors of a number, and like if you couldn't figure out which numbers multiply to 15, I don't know how you would do this process, right? There is a method called the Australian method that maybe in that case you might be able to get away with it without knowing your times tables as well. So you could Google that if you wanted to, if you were interested in a different way of doing it. But anyway, it would be a lot slower and a lot harder if you didn't know your times tables, didn't know factors of numbers. So that's why sometimes just knowing them can actually be helpful. All right, let's see what we have here. 4 times 5 is 20. 3 times 3 is 9. 20 plus 9 is 29.